The global energy sector is currently at a crossroads. With the increasing pace of economic growth and development, the demand for energy is growing at an unprecedented rate. The consequences of our activities present us with challenges that impact the climate, human health, and security. While many countries have other power sources, fossil fuels remain the primary energy source, accounting for approximately 80% of global demand. So, what are fossil fuels? Fossil fuels, including oil, coal, and natural gas, are a key component in shaping the energy mix. Oil fuels the transportation industry, powering cars, ships, and planes. Coal is widely available for power generation, especially in developing countries. Natural gas, often touted as a cleaner fossil fuel, releases less CO2 when burned compared to coal. However, despite being used for heating, fossil fuels lead to the emission of greenhouse gases that contribute to global warming. In the face of climate change and the gradual depletion of fossil fuel reserves, having adequate alternative energy sources becomes imperative. The burning of coal and gas leads to the emission of CO2 as well as harmful gases that have a detrimental impact on human health and ecosystems. Moreover, fossil fuel deposits are finite, meaning their availability will decline, which could result in increased costs and conflicts over access to resources. Choosing energy sources such as solar, wind, and geothermal power allows for the use of energy in a sustainable and environmentally friendly manner. Alternative solutions that do not emit greenhouse gases, while ensuring energy security, make us less dependent on fossil fuel sources and reduce the risk of armed conflicts. Fossil fuels, such as coal, oil, and natural gas, are the primary sources of energy for conventional electricity generation. The electricity produced from these fuels is generated through a combustion process in power plants. During combustion, heat is released, which is used to produce steam. This steam drives a turbine, which in turn drives an electric generator, producing electricity. Coal and natural gas are most commonly used to power large industrial power plants. Oil has a wide range of applications and is used in many industries. The combustion of fossil fuels leads to significant emissions of carbon dioxide, CO2, which is the primary greenhouse gas. CO2 traps heat in the atmosphere, contributing to the greenhouse effect and global warming. The increase in atmospheric CO2 concentration causes an increase in the average global temperature, leading to climate change and disrupting ecosystem balance. In addition to carbon dioxide, CO2, the combustion of fossil fuels also emits other harmful substances, such as nitrogen oxides, NOx, sulfur dioxide, SO2, and particulate matter. These pollutants enter the air and can cause serious health problems in humans, such as respiratory and cardiovascular diseases. The extraction and combustion of fossil fuels have a negative impact on the environment and human health. This process often involves open-pit mining, which leads to land degradation and groundwater contamination. Additionally, the extraction and transportation of fossil fuels can cause accidents that lead to soil, water, and air pollution. These activities destroy natural habitats, reduce biodiversity, and contribute to climate change. Carbon capture and storage, CCS, is one of the most advanced technologies aimed at reducing carbon dioxide emissions. The CCS process involves capturing CO2 directly from the flue gases produced during the combustion of fossil fuels. The captured carbon dioxide is then compressed and transported to specially designated storage sites, such as deep geological formations underground. This ensures that CO2 is safely isolated and does not enter the atmosphere. Co-firing technologies involve the simultaneous combustion of fossil fuels with other materials, such as biomass. This can reduce the amount of CO2 emitted, as some of the energy comes from burning biomass, which is a renewable source. However, co-firing does not completely eliminate CO2 emissions. Electrostatic precipitators and catalytic filters are devices used in coal and gas-fired power plants to clean flue gases. Electrostatic precipitators and catalytic filters capture pollutants such as nitrogen oxides, sulfur dioxide, and particulate matter, which are harmful to human health and the environment. They can significantly reduce emissions of these substances. Modern boilers and turbines used in power plants are more efficient than older models. This means that less fuel is required to produce the same amount of energy, leading to lower CO2 emissions. The above technologies can help reduce greenhouse gas emissions and other air pollutants from power plants. However, they're not a perfect solution and have their limitations. These technologies are expensive to implement and require time and appropriate infrastructure. Furthermore, to achieve global climate goals, it is necessary to gradually phase out fossil fuels and transition to more sustainable energy sources, such as renewable energy. The transportation sector is a primary driver of global warming, being the largest consumer of fossil fuels. Petroleum and its derivatives, such as gasoline, diesel, and jet fuel, power most modes of transportation, significantly contributing to greenhouse gas emissions. Road transport dominates this sector, with cars, trucks, buses, and motorcycles as the main culprits. Emissions are particularly high in urban areas with heavy traffic. Aviation is one of the fastest-growing segments, but decarbonization is extremely challenging. Special jet fuels based on petroleum are necessary to ensure the safety and efficiency of flights at high altitudes. Maritime transport also relies on fossil fuels, primarily heavy oil. Although maritime transport is more efficient over long distances, its contribution to global emissions is significant. Rail transport, while electrified in many regions, still relies heavily on diesel locomotives, especially on routes outside major urban areas. The development of batteries and the decrease in their costs have led to the rapid growth of electric vehicles. Zero-emission and powered by renewable energy, they offer a real alternative to internal combustion engine vehicles. Combining a combustion engine with an electric one, hybrid vehicles reduce fuel consumption and CO2 emissions, especially in urban traffic. Produced from plants, such as bioethanol and biodiesel, can partially replace fossil fuels, especially in aviation and shipping. Hydrogen fuel cells are a promising technology for heavy-duty transport, offering a zero-emission solution. Barriers to transportation transformation. The development of electric vehicles requires an extensive network of charging stations. While hydrogen vehicles require refueling stations, batteries have limited range, and hydrogen production is costly. Electric and hybrid vehicles are more expensive than traditional cars. Battery production requires rare metals, the extraction of which has environmental costs. Heavy equipment and long distances make decarbonization of these sectors difficult. Despite the challenges, the transformation of transportation is inevitable. Technological development and growing environmental awareness are driving change. In the long term, it will be possible to create a more sustainable and environmentally friendly transportation system. The transportation sector is one of the largest emitters of greenhouse gases. To limit global warming, decarbonization of this sector is necessary. Although there are barriers, technological progress and new solutions are paving the way for a more sustainable future. Another branch is heavy industry. The steel production process in steel mills relies on burning coke in furnaces that reach very high temperatures, required to reduce iron ore and convert it into steel. This process emits huge amounts of CO2, as carbon not only generates the necessary heat, but also participates in the chemical reaction in which steel is formed. Cement is produced by burning raw materials such as calcium and silica in rotary kilns at temperatures reaching 1,400 to 1,450 degrees Celsius. To generate such temperatures, fossil fuels, most often coal or natural gas, are used. Moreover, the chemical process in which calcium is decomposed also emits CO2, contributing to additional emissions. Fossil fuels, especially natural gas and petroleum, are crucial in the production of chemicals. They are not only a source of energy for heating reactors, but also a raw material for the synthesis of many chemical products, such as plastics, fertilizers, and pharmaceuticals. The difficulties in decarbonizing these sectors include the production of steel, cement, and some chemicals requires very high temperatures, which are difficult to achieve using current renewable technologies. Coal and gas are currently the only energy sources that can provide the necessary heat efficiently and continuously. CO2-emitting chemical reactions in some processes, such as cement production, CO2 emissions are not only the result of fuel combustion, but also a natural product of chemical reactions. making emission elimination more complex than in other sectors. New technologies, such as green steel or alternative cement production methods, are still very expensive. Many industrial plants would have to be modernized or completely rebuilt, which involves huge financial costs. Industry resistance and the long life cycle of infrastructure industrial plants have a long life cycle and are often adapted to specific fossil fuels. The transition to new technologies would require huge investments and changes in technological processes, which may meet with resistance from companies and governments. Examples of new technologies include green steel production using hydrogen. One of the most promising solutions is the production of steel using hydrogen as a reducing agent instead of coke. In this process, instead of CO2, water is produced as a byproduct, which significantly reduces emissions. The first plants testing green steel, such as H2 Green Steel in Sweden, are already being built and could revolutionize the steel sector. Alternative cement production methods. New technologies, such as Belite cement or geopolymer cement. Geopolymer cement is produced from waste materials such as fly ash, which can reduce emissions by up to 80% compared to traditional methods. Another solution is technologies that allow for the capture and storage of CO2 directly from cement kilns. The chemical industry can reduce its emissions by switching to biomass as a raw material. For example, biomass can be processed into bioplastics and other bioproducts, which reduces the dependence on petroleum. The chemical industry is also researching the synthesis of materials based on renewable sources and the capture of CO2 as a raw material for the production of chemicals. In the heavy industry sector, the capture of carbon dioxide directly from flue gases and its storage underground is increasingly being used. CCS can help reduce emissions, but its implementation is costly and requires appropriate geological structures. These innovative technologies are a step towards decarbonizing heavy industry, but their widespread implementation will require significant investment and political support. The transformation of these sectors is a long-term process, but it is crucial for achieving climate neutrality. Absolutely. Here's a translation of the text, incorporating some minor improvements for clarity and conciseness. How fossil fuels impact agriculture. The production of artificial fertilizers, particularly nitrogen fertilizers, heavily relies on natural gas as a hydrogen source for ammonia synthesis. 1,1-ammonia is the primary component of nitrogen fertilizers, essential for intensive agriculture. This process is highly energy-intensive and releases significant amounts of CO2, making fertilizer production a major source of agricultural emissions. 2. Traditional agricultural machinery, such as tractors, combines, and sprayers, is powered by diesel fuel, generating carbon dioxide emissions and air pollution. In intensive agriculture, fossil fuel consumption is very high, increasing production costs and burdening the environment. The food industry, from production to distribution, is highly dependent on transportation, which also relies mainly on fossil fuels. Transporting food over long distances requires the use of trucks, ships, and airplanes, contributing to the high carbon footprint of the global food supply chain. Food processing, including cooking, freezing, drying, and packaging, is energy-intensive and often relies on fossil fuels, especially in larger processing plants. Many of these processes require a constant supply of thermal energy, which currently comes from gas or coal. In response to the high consumption of diesel fuel by agricultural machinery, biofuels are becoming a popular alternative. Biofuels such as biodiesel can be produced from vegetable oils or organic waste and have a lower carbon footprint than traditional fossil fuels. In some regions, farmers produce biofuels locally, reducing transport emissions. The introduction of electric agricultural machinery is one of the most promising innovations. Electric tractors and combines are increasingly being tested and can significantly reduce CO2 emissions. Moreover, if charged with energy from renewable sources such as solar or wind power, they can become completely independent of fossil fuels. As the technology for producing green hydrogen develops, the fertilizer industry is beginning to introduce alternative methods that do not use natural gas as a hydrogen source. Green hydrogen, produced using renewable energy, can revolutionize fertilizer production by lowering its carbon footprint. Agrivoltaics, combining solar panels with agricultural production, is an innovative solution that allows farmers to simultaneously generate energy and grow crops. Solar panels are installed above fields, providing shade for some crops and generating electricity that can be used for farm needs. Innovations in logistics can reduce the reliance on fossil fuels. Using electric vehicles for short-distance food transport and developing local markets reduces transport-related emissions. Focusing on shorter supply chains, such as local production and sales, can minimize the need for long-haul fuel transport. Within a circular economy, the food industry can reduce emissions by using organic waste to produce energy, e.g., biogas and fertilizers. Biogas is produced by fermenting food waste, reducing the need for fossil fuels and emissions associated with waste. Thanks to these alternatives and innovations, agriculture and the food industry can significantly reduce their dependence on fossil fuels and contribute to achieving climate goals. Alternatives to fossil fuels include wind, solar, hydro, and geothermal energy. Wind turbines convert the kinetic energy of the wind into electrical energy. Wind farms are among the fastest-growing renewable energy sources and can be installed both on land and at sea, where the wind is more stable and stronger. Currently, wind energy is a key element of the energy transition in many countries, especially in Europe and the United States. Solar energy is primarily used by photovoltaic panels, which converts sunlight into electricity. A major advantage of photovoltaic panels is the ability to install them on building roofs, enabling decentralized energy production. Another application of solar energy is concentrated solar power plants, which focus sunlight to heat a fluid and generate steam to drive turbines. Hydroelectric power plants utilize the energy of flowing water to drive turbines. The most common type of hydroelectric power plant is a dam, but other technologies exist, such as pumped storage hydropower and marine turbines, tidal and wave, that harness the energy of the oceans. Hydroelectric energy is a stable and efficient source of energy, although it depends on local geographic conditions. Geothermal energy originates from the Earth's interior and is used for heating or electricity generation. Hot geothermal waters located near the surface are particularly valuable in countries with geothermal activity, such as Iceland. Geothermal energy can be a stable source of energy, available regardless of weather conditions, although it requires suitable geothermal resources and infrastructure. The development of energy storage and its importance in the transition to renewable energy. Why is energy storage important? One of the main challenges in transitioning to renewable energy is its variability. Sources such as wind and solar energy depend on weather conditions and time of day, which can lead to fluctuating energy supply. Energy storage allows for the storage of excess energy produced and its use when production is low. This makes the energy system more stable and less dependent on fossil fuels. Energy storage technologies include lithium-ion batteries. The most commonly used batteries in energy storage today, lithium-ion technology is well known from its applications in electronics and electric vehicles. On a large scale, lithium-ion batteries can store energy for households and entire power grids. Flow batteries, such as vanadium, store energy in electrolyte solutions. They are more durable and can store large amounts of energy for longer periods, but they are also more expensive and larger than lithium-ion batteries. One of the oldest and most efficient methods of energy storage is pumped storage hydropower, in which water is pumped to an upper reservoir during periods of excess energy production and then released to generate electricity when needed. Hydrogen is an alternative method of energy storage. In the electrolysis process, excess renewable energy can be used to produce hydrogen, which can then be stored and used as a fuel, including for generating electricity in fuel cells. Energy storage increases the flexibility of the energy system, reduces the need for overproduction, stabilizes power grids, reduces the risk of outages, and facilitates the integration of various renewable energy sources. Energy storage technologies still have their limitations, including high investment costs and a shorter lifespan of some types of batteries. The efficiency of converting energy to hydrogen and back is also lower than with direct storage in batteries. The development of energy storage technologies is a key factor in achieving independence from fossil fuels and building a sustainable energy system based on renewables. Investing in the development and deployment of new storage technologies will accelerate the energy transition and allow for more efficient use of green energy. What is green hydrogen? Green hydrogen is hydrogen produced using renewable energy without emitting carbon dioxide. It is a clean alternative to hydrogen produced from fossil fuels, which currently dominates the market. It is produced through electrolysis, a process where water is split into hydrogen and oxygen using electricity generated from renewable sources such as solar and wind power. The potential of green hydrogen. Green hydrogen can play a crucial role in reducing greenhouse gas emissions as it is a clean-burning fuel, producing only water as a byproduct. It is considered a promising future replacement for fossil fuels, especially in sectors where it is difficult to replace them with other energy sources. Hydrogen has the potential to replace fossil fuels in high-temperature industrial processes such as steel, cement, and chemical production. For example, green steel can be produced using hydrogen instead of coking coal, reducing emissions associated with its production. Hydrogen can also be used as a raw material in the production of ammonia and other chemicals. Hydrogen is an ideal fuel for transportation sectors where batteries are difficult to apply, such as heavy-duty trucks, trains, ships, and airplanes. Hydrogen fuel cells can provide longer ranges and faster refueling times compared to electric batteries. Although electric battery vehicles dominate this segment, hydrogen is also being tested as an alternative. Hydrogen offers the possibility of fast refueling and long ranges, which can be beneficial in regions with limited charging infrastructure. Hydrogen can be used to generate electricity, especially during periods when renewable sources such as the sun or wind are unavailable. Hydrogen can be stored and used in power plants as a backup fuel, increasing the stability of the power grid. Hydrogen acts as an energy carrier, allowing for the storage of excess renewable energy in the form of fuel. It can be stored for long periods and converted back into electricity when needed, which is crucial for the stability of a renewable-based grid. Currently, producing green hydrogen is more expensive than producing hydrogen from natural gas. Hydrogen production through electrolysis requires a large amount of energy, and the cost of this technology is still relatively high. The lack of infrastructure for transporting, storing, and distributing hydrogen is a barrier to its widespread use. Currently, there are few hydrogen refueling stations, limiting its availability, especially in the transportation sector. The process of producing hydrogen, storing it, and converting it back into electricity involves energy losses. Hydrogen is less energy efficient compared to the direct use of electricity from renewable sources. As the cost of renewable energy decreases and electrolysis technology develops, the production of green hydrogen can become more profitable. Many countries are investing in increasing production scale and developing more efficient electrolyzers. Governments and energy companies are working on developing hydrogen transmission networks and integrating hydrogen into existing gas pipelines, which can facilitate its distribution and large-scale use. Research on hydrogen technology is also focused on developing more efficient fuel cells and improving hydrogen storage capabilities, which can open up new applications such as powering homes or portable devices. As governments and international organizations introduce ambitious emissions reduction targets, hydrogen is gaining importance as a key element of the global energy transition. In the long term, hydrogen can become a common fuel in sectors where it is difficult to replace fossil fuels. International cooperation and the development of regulations supporting the production and use of green hydrogen can accelerate its adoption and help overcome barriers. Accelerating the production and use of green hydrogen will have a positive impact on the environment, reducing greenhouse gas emissions and helping to achieve climate goals, benefiting both current and future generations. Green hydrogen is a promising technology that can become a key component of the global energy system. Despite current challenges, growing investments, technological progress, and regulations supporting sustainable development can make hydrogen the fuel of the future, supporting the world's transition to clean energy sources. What changes need to happen to eliminate fossil fuels? To effectively eliminate fossil fuels, it is necessary to increase the share of renewable energy in the global energy mix. This includes developing solar, wind, geothermal, and hydropower technologies, as well as innovations in energy storage that will enable stable power supply. Transformations in the electrification of the transport sector and increasing energy efficiency in buildings and industry are key. Changing the approach to transport, including the development of electric vehicles and public transport systems, will significantly reduce the demand for fossil fuels. The introduction of green hydrogen and other low-emission technologies in the industrial sector, especially in the production of steel, cement, and chemicals, is essential to reduce emissions. Investments in innovative technologies and efficient production processes can significantly reduce the carbon footprint. It is crucial to increase public awareness of the impact of fossil fuels on the environment and health. Consumers can influence the market by choosing environmentally friendly products and investing in environmentally friendly technologies. Transparency and accountability on the part of producers and energy suppliers can encourage the use of more environmentally friendly solutions. International cooperation, investments in new technologies. Countries must cooperate within the framework of international agreements, such as the Paris Agreement, to set common goals and a strategy for combating climate change. By sharing technology, knowledge, and resources, countries can jointly change their approach to energy. Developing countries may need support from more developed countries in terms of access to clean technologies and financing. Technology transfer and financial support are key to enabling them to undergo an energy transformation. Governments, research institutions, and the private sector must invest in research and development of new technologies that will increase energy efficiency and enable the transformation of energy systems into more sustainable ones. Examples include innovations in batteries, fuel cells, and carbon capture technologies. The introduction of incentives for investments in clean energy, such as subsidies, tax breaks, or technology development funds, can accelerate the transition to renewable energy sources. Remember, our future depends on the decisions we make today. Together, we can build a more sustainable world where our energy needs are met in an environmentally friendly way. I encourage you to explore and invest in renewable technologies to become part of the solution, not the problem. Together, we can create a future where energy is clean, sustainable, and accessible to all. Would you like me to translate this into another language? Or perhaps you'd like me to focus on a specific aspect of the text, like the role of government policy or the potential of renewable energy technologies.